waste our class for that. Okay, already it is being given there. You can write and submit that. Okay.
So in that some data is problem ಆಗಿದೆ.
ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಿದೆ?
ಎಫಿಷಿಯನ್ಸಿ ಹೆಚ್ಚು ಸಿಕ್ತುಂಟು ಸರ್.
Efficiency
160%.
160.
very good. So your engine is excellent ಹಾಗಾದ್ರೆ. We'll check that. We'll check the data. Okay, no issue. Don't worry about the assignment. Assignment will be given. A neat question paper will be given. You can solve it and give it in your Google Classroom. Don't worry about it. Just concentrate on the problems as of now.
So do we need to submit that sum?
If it is wrong, why will you submit then?
Okay.
If you get the right answer, then you can submit.
Sir, questions ಕೊಡ್ಲಿಲ್ಲ ಸರ್ ನೀವು?
ಯಾವ ಕ್ವಶನ್ಸ್?
ಅದೇ ಅಸೈನ್ಮೆಂಟ್ ಗೆ
ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಉಂಟಲ್ಲ.
ಓಕೆ.
The heat balance is correct, but the efficiency are wrong.
Most of the parameters which is related to IP would be wrong. That's why your IP value would be very less. Okay, it should be more than BP, no? If it is more than BP, then it should be below 100%. If IP value was less than your BP, then it would be more than 100%. So simple funda there. Okay. Let us take this particular problem. This problem is, you can see how many times it has been repeated. So it has been repeated in Jan 2019. First it was asked in Jan 14. Next July 2017. Next presently it has been asked in Jan 2019. Let us look into the problem now. Okay. First, a gas turbine unit has a pressure ratio of 6:1. So what do you mean by pressure ratio? First of all, he says gas turbine unit. So automatically you have to understand that gas turbine would run on a Brayton cycle. So immediately what you have to do? You have to draw your Brayton cycle first. So I will just write given data. Okay. Now start to draw your Brayton cycle. Brayton cycle is simple. Just draw two lines like this, one curve. And start the point from here, process 1 to 2, adiabatic compression. You have to remember the process, because whenever you remember the process, you can apply the suitable formula, isn't it? Next, 2 to 3 is isobaric heat addition. Next, 3 to 4 is adiabatic expansion. And 4 to 1 is isobaric heat rejection. Same thing, it is better to plot on the TS diagram also. Since 1 to 2 is an adiabatic compression. Adiabatic in the sense it is isentropic, so that S remains constant from 1 to 2. Later on, it increases its temperature because of the heat addition isobarically from 2 to 3. Later on, from 3 to 4, it expands isentropically, keeping the entropy constant, and it comes back to the original position by rejecting heat isobarically again. Okay, so this is the diagram. PV and TS diagram immediately have to draw. Good. Next, so as soon as we have heard this word, gas turbine unit, we assumed this particular unit runs on the Brayton cycle, and we have drawn a Brayton cycle. He says has a pressure ratio of 6:1. Now, what is this pressure ratio? Pressure ratio is nothing but beta, which is given by P2 by P1, or it is given by P3 by P4. Either of the things. P2 by P1, because since 2 is equal to 3 and 1 is equal to 4, either of the things you can take, 3 by 4 or 2 by 1. So that is given as 6. I would just write it here. So next, the maximum cycle temperature. Maximum cycle temperature. So he's talking about the temperature. Maximum cycle temperature is 610 degrees Celsius. He has given. Now, which temperature is that? Is this T1? Is this T2? Is this T3? Or it is T4? Which one is that? He says maximum cycle temperature is 610 degrees Celsius. Which one is
T3.
that? Exactly. So if you observe, T1 is attained this level, T2, T3, and T4. So T3 is maximum. So I will take T3 as how much? 610. So directly convert into Kelvin, 610 plus 273. 610 degrees Celsius plus 273. It would be converted into Kelvin. Give me the value of T3 in Kelvin.
883.
883. The isentropic efficiency of the compressor he has given. Now, where does the compression happen? Compression happen in this particular process of 1 to 2. So since he has given the isentropic efficiency of compressor as 0.8 and isentropic efficiency of turbine as 0.82, you have to understand that this particular process, whichever is there, will not go as an ideal one, which is indicated here, but it will deviate to a certain extent. That deviation you can mark it like this. So it deviates like this to meet at 2 dash. And similarly, as isentropic efficiency of turbine is given, so turbine carries out the process of 3 to 4, which is expansion. So since efficiency is being given, we are understood that it will not go in the path specified by the Brayton cycle. Rather, it will just deviate its path a little bit like this. So to meet at 4 dash. Similarly, the same thing I would be drawing in case of TS diagram also. So it will not go as indicated in the Brayton cycle, but it will deviate to a certain extent like this. So meet at 2 dash and 4 dash. So efficiency of why we have come to this particular conclusion. Why we have come to this particular conclusion that it is deviating from the path of compressing and expansion? Just because he has given the values of efficiencies of turbine as well as the compressor. Now, what we are supposed to do? To find. So we are supposed to find what? Power output. So we are supposed to calculate the power output of this particular thing. Now, when the air enters the compressor at 15 degrees Celsius, he says air enters the compressor at 15 degrees Celsius. That means, where is the compressor process? Whether it is 1 to 2, 2 to 3, 3 to 4, or 4 to 1. Which one is the compressive process? Which one is the compression process?
1 to 2.
1 to 2 is a compression process. Now, he says air enters the compressor at 15 degrees Celsius. That means, should I take it as T1 is equals to 15 or T2 is equals to 15? He's talking about the entering into the compressor.
T1.
T1, right? So I would take T1 as much 15 degrees Celsius. Now immediately convert this into Kelvin by adding 273. 15 plus 273, this would come around 288. Am I right?
Yes, sir.
288 Kelvin. So T1 is 288 Kelvin. Very good. Any other data given? Very good. 15 degrees Celsius is done. Next. At the rate of 16 kgs per second. So this is the mass flow rate of air which he is being given. I would just write mass flow rate of air is 16 kg per second. So it was 16 kg per second. I have just written it down. Next, take the value of Cp is equals to 1.005 kilojoules per kg Kelvin and gamma is equals to 1.4 for compression and Cp is equals to 1.11 kilojoules per kg Kelvin and gamma is equals to 1.333 for expansion. So he has given two different values. I would just write it up. So for compression, and for expansion, he has given the two different values. For compression, the value of Cp is how much? 1.005. Exactly, it is kilojoules per kg Kelvin. And the value of gamma for compression is 1.5. Next, for expansion, he has said that the value of Cp would change to 1.11 kilojoules per kg Kelvin. And similarly, the value of gamma would be 1.333. So these are all the data he has been given. So any other data which is being specified in the problem but not being listed. Whether I have covered all the data which is being given in the problem?
Yes, sir.
Right. Now, what we have to do is, we need to calculate the power output, isn't it? Now, power output is given as solution. I would just start the solution from here. Okay, solution. Now, power output is given as simple. It is mass flow rate of the air into W net. You can take the cyclic W net or just W net. You can write W net. Right. Now, what do you mean by W net? So, how many types of works are there in this particular Brayton cycle? How many?
2.
2. What are those? The turbine work as well as the compressive work. Okay. Now, I taught you how to calculate your value of turbine work and how to calculate the value of compressive work. Now, see, one thing is that I told you it is mCp delta T. Okay, it is mCp delta T. What you do is the power output is nothing but, for the initial problems, it will be confusing for you. What you do is just take power output as W net. So whatever the difference in the work is there, overall work output is there, that is your power output, which is nothing but W net. Now, how will you calculate the W net now? That means, how will you calculate the W net in the sense, it is the summation of the turbine work output plus compressor work output, correct? Now, how will you calculate WT? I told you it is mCp delta T. Whether it is work or it is heat, it is mCp delta T. How will you do for the turbine work? Just look for where is the turbine. So 3 to 4 is the turbine, correct?
Yes, sir.
Or no? Now, for work, it is initial minus final or final minus initial?
Initial minus final.
So for work, it is initial minus of final, right? So now, turbine work output, same, use this particular formula, mCp delta T, it is m dot into Cp into, I have to write the temperature difference. Now for work, it is initial minus final. My process is from 3 to 4. What should I write?
T3 minus T4.
Excellent. Now, T3 minus of T4. So since efficiency of the compressor is being given, I have to take not T4, but I have to take T4 dash. That's my point.
Yes, sir.
Very good. Now, all of you just say this for compression work. Compression work is carried out from the process 1 to 2, right? Now, same thing again, it is mCp delta T, and for the process 1 to 2. So I would write m dot into Cp. Now, the process is from 1 to 2, compression work. So how am I supposed to take the temperature difference?
T1 minus T2 dash.
Excellent. T1 minus T2 as in case of an ideal thing, but since the efficiency of the compressor is being given, you have to take it as T1 minus T2 dash. Any doubts until now? Any doubts? Any doubts? Understood up till now? Because this is very important. This is the whole heart of the problem. This is a new thing what you learn in ATD. Now, rest all is BTD. Okay. Any doubts until now? can at least reply in the chat box, man.
No.
Okay. Okay. Now let us check what all the parameters we have and what all the parameters we need to calculate. Okay. Now, do I have the value of m dot? Now let us start to calculate the value of Wt. Now we will start to calculate the value of Wt. For Wt, do I have the value of m dot being given in the problem? Do I have it?
Yes, sir.
And do I have the value of Cp given for the turbine work or
Yes,
for
sir.
expansion work?
Yes.
Do I have the value of T3?
Yes, sir.
Do I have the value of T4 dash?
No, sir.
I don't have the value of T4 dash. So in order to find now the unknown what I have, I would just write it here. Okay, in order to find the T4 dash, initially I should find T4. Yes or no? Later I can convert it into T4 dash by using efficiency. Now, how do I find the value of T4? How do I find the value of T4?
PVT conversion.
Excellent. So take the process from 3 to 4, which is adiabatic expansion. Now, what is the PVT conversion equation for the process 3 to 4, which is adiabatic compression? So it is P3 by P4. That is equal to same thing, man. V4 by V3 whole to the power of gamma. That is equal to T3 by T4 whole to the power of gamma divided by gamma minus 1. Now, in this particular expression, so I would take these two. Okay. I would pick these two. It is P3 by P4 is equals to T3 by T4 whole to the power of gamma divided by gamma minus 1. Excellent. Now, what is P3 by P4, guys? Can I take it as beta pressure ratio? P3 by P4?
Yes, sir.
So that value is how much? That value is 6. That is equal to T3 value is 883 divided by T4 whole to the power of gamma value in case of an expansion is given as 1.333 divided by 1.333 minus 1. Now, in this particular expression here, only unknown parameter is T4. Can I get the value in Kelvin? If you want, you can apply LAN on both sides and solve it. You can solve this, no? Or should I solve this? Should I solve this? Either you can use your calculator directly. I think I've taught you in the class. ಕೊಟ್ಟಿರೋದೀಗ T4 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ?
$566.
Okay, I will take that value. How much is that? 566. Others, just check the value. Is it right? You can just solve this simply, man. Apply LAN on both sides. So 6 is equals to 883 divided by T4 whole to the power of 1.333 divided by 1.333 minus 1. Now, LAN of 6 is equals to LAN of this whole thing. Okay, when you apply LAN of the whole thing, okay, So what happens to the power then? Ln of m to the power of n is what?
N into.
Just solve that same thing. You would get it. Okay. On the other hand, you can use your calculators. Just type this whole lot of equation directly in the calculator. Sometimes it leads to the wrong results. I have found that whenever there is a LAN involved, it leads to a wrong result. Be careful about it.
Sir, 64, 564.37.
Okay. How much is the value correct?
564.
564. Huh?
Yeah, sir. 564.37.
Very good. Now 564.37. Now, since the value of T4 is obtained, what is our next step? You have to convert the value of T4 into T4 dash. For that, efficiency of the compressor is being given. Now, how will you calculate efficiency of the compressor? Sorry, efficiency of the turbine. What is the efficiency of the turbine? It is actual work divided by the theoretical work. Or theoretical work can also be called as isentropic work. Any other thing you can use. What is actual work? What is theoretical work? Both are work. Theoretical work in the sense it is something which is related to this. Okay. So this is theoretical one. Correct? Where nothing is involved. Where it is deviating in the sense this is actual thing which is happening. We are assumed that it would happen from 1 to 2, but actually it is happening from 1 to 2 dash. Now, how will you calculate actual work? Again, same thing, man. It is MCP delta T, right? For work, it is what? For work, it is initial minus of final. Same thing again. MCP. Now I am calculating for the actual one. Actual one in the sense, which is in the red color. What is the temperature difference? Can I write it as T1 minus of T2 dash? Actual thing. For the theoretical, or for, you can even call it as isentropic work. Again, it is MCP delta T. Now, but the delta T you have to consider for the theoretical one, which is this, without the dash. That is T1 minus T2. Am I right? Shall I pick this particular formula there? Yes or no? Take that particular formula. Where I was there? Actual work. Actual work, it is MCP into actual in the sense dash will come. So T3 minus T4 dash. Theoretical in the sense dash will not come. Ideal thing. T4. MCP get cancels. So it is T3 minus T4 dash divided by T3 minus of T4. Now, efficiency of the turbine is how much given? It is 0.82, correct? 0.8 or 0.82? 0.82. That is equal to T3. How much is the value of T3? 883 minus of T4 dash that you have to find divided by T3 again. It is 883 minus T4. You have just found out it is 564. Yes. So from this, finally, I got the value of T4 dash. How much is the value in Kelvin?
618.96.
6
18.96.
96. Just check the value. Just check. Is that right? Now, once T4 dash is calculated, now calculate the turbine work output. Here it says MCP into T3 initial minus final T4, but it is, since efficiency is given, it is T4 dash. Now, M dot is given as how much? 16 kgs per second something, isn't it? It is 16 kgs per second cross. CP value is how much for the expansion? 1.33. So 1.33 kilojoules into T3 is 883 minus T4 dash is
1.11, sir.
The T4 dash is 621.42, sir.
Okay. So which one I'm supposed to take?
621.
Okay. $621.4. 42.
Yes, sir.
Same value ತಗೊಂಡಾಗ work done calculate ಮಾಡಿ ಪಟ್ಟ 621.42. Now just check the units again.
Sir, CP 1.11.
1.11 na expansion ಮತ್ತೆ ಇದಕ್ಕೂ ನೀವು 1.33 ತಗೊಂಡಿದ್ದೀರಾ 3 to 4 ಗೆ. Here also it should be 1.11, no? Yes or no? Oh, that is gamma. Gamma is how much? Gamma is 1.3.
1.3.
Correct. 1.11. Now just check the units, guys. So m dot is in kgs per second. CP have substituted in kilojoules per kg Kelvin cross the temperature value is in Kelvin. Now what happens? Kelvin goes away. Kg goes away. So whatever is remaining, kilojoules per second. Joules per second is watt. So it is kilowatt. Now whatever the answer you get, that would be in what? That would be in kilowatt. That is the answer.
$4,645.66, sir.
Kilowatts alla answer direct agi
Yes, sir. 4645.66.
4645.66 kilowatts. Okay. So this is your turbine work. Next ಈಗ compressive work ಗೆ ಬನ್ನಿ. Compressive work, how will you calculate? Compressive work is given by M CP. This is M dot CP. Compressor work is from 1 to 2 and the compressor efficiency is given initial minus final T1 minus T2. Since compressor efficiency is given, I would take T2 dash. I know the value of M dot, I know the value of CP, I know the value of T1, but I don't know the value of T2 dash. Now, in order to calculate the value of T2 dash, I require the value of T2. How will I calculate the value of T2? Again, I have to go with PVT conversion equation for 1 to 2, which is adiabatic compression. What is the PVT conversion equation for 1 to 2, which is adiabatic compression? It is P1 by P2, that is equal to V2 by V1 whole to the power of gamma, that is equal to T1 by T2 whole to the power of gamma divided by gamma minus 1. ನಮಗೆ V2 V1 ಸಂಬಂಧ ಇಲ್ಲ, just take P1 by P2. What is P1 by P2? What is P1 by P2? P2 by P1 is beta, right? So P1 by P2, can I take it as 1 by beta? That is equal to T1 value how much? T1 value
288.
divided by T2 whole to the power of gamma. 1.4 for compression, 1.4 minus 1. From this, the value of T2 is how much? In Kelvin. Now, once you got T2, we will calculate T2 dash using compression efficiency.
Four 480.53 Kelvin, sir.
480.53. Now, since the value of T2 is known, now what you have to do, you have to use compressor efficiency. What is compressor efficiency? It is ulta of turbine efficiency. It is isentropic work. Isentropic work or theoretical work. This is also called as theoretical work divided by the actual work. Okay. Isentropic work anta andre enu, where dash is not involved. So it is mCp, m dot Cp into T1 minus of T2 is whole divided by actual anta dash baratte. Whenever there is a word actual, think that there would be a dash. So it is actual dash baratte. So it is m dot Cp into T1 minus of T2 dash. Now these two will go away. Now compressor efficiency is 0.8. T1 is how much? 288 minus of 480.53 is the value of T2 divided by 288 again minus of T2 dash is, that is the value we have to find out. So from this, what is the value of T2 dash in Kelvin?
$528.66 Kelvin.
528.66 Kelvin. Now, once that value of T2 dash is known, no one can stop you from calculating the value of work of a compressor. It is m dot Cp, initial minus final. 1 to 2 is the process. So T1 minus T2. Now, since the efficiency of compressor is given, it is dashed. M dot is how much? 16. Cp value of idu estu? 1.005 into 288 minus 528.66. Now, we have matched the unit in the previous thing, so no need to match it again. So whatever you get, that would be in kilowatts directly.
Sir, minus 3,869.81.
Minus 3,869.81.
81.
Yes, it is right. Because compressor, in the sense you are working on the system, you are losing work for the system to perform. So it is minus. Now, W net, first of all, what we need to calculate is power output, right? The power output is given as W net, and W net is the summation of WT plus WC. How much is the value of the WT, which we have got?
4645.66.
Correct. I would just place it here. properly and put it in a box. WT 4645.66. 4645.66. WC is how much? Compressor. It is minus 3869.81 kilowatt. Now, what is the value of power output?
Seven 775.85 kilowatt.
775.85 kilowatt, and there it ends your problem. So if you do this, you would get 12 marks straight away. Okay. Understood the problem? Any doubts in this? Any doubts in this particular problem?
No, sir.
No, sir.
Okay. Now, will you try the same thing again? The same problem? Just take this particular problem. Thousand 18 Corona. Use photo. Crop. So this is 2018 problem. Okay. A similar one, last a bit, there is an requirement of calculation of cycle efficiency. We'll do it. Okay. All of you just write the problem and try to solve this. Meanwhile, I'll take the diagrams from there. Okay. Again, it is based on this Brayton cycle. Again, efficiency is being given. So it is the same thing there. Okay. Now, but here the pressure ratio is not being given directly. You have to calculate it. So air standard Brayton cycle. The air enters. In the air standard Brayton cycle, the air enters the compressor at 0.1 megapascal. Air enters the compressor at 0.1 megapascal in the sense, and 15 degrees Celsius in the sense, the pressure value and the temperature value is being given. At which state? Whether it is at state 1, whether it is at state 2, whether it is at state 3 or what. At which state he has given. Air entering the compressor. Should I consider it as 1? Should I consider it as P1? Should I consider it as P1 and T1? Or should I consider it as P2 and T2? Which value should I consider these as?
P1, sir.
Very good. So I would just write P1 is equal to 0.1 megapascal and T1 is equal to 15 degrees Celsius. What is the value in Kelvin? just write it here. Next, the pressure leaving the compressor is 1 megapascal. So what is that pressure leaving the compressor? Which value is that? P2. Very good. So the pressure leaving the compressor is P2. That is 1 megapascal. I think now I can calculate the value of pressure ratio. I know the value of P2. I know the value of P1. Just substitute here. P2 is 1 megapascal, whereas P1 is 0.1 megapascal. So what is the value of pressure ratio?
Ten megapascal.
10. There is no
10,
megapascal.
10, sir,
10.
10.
Oh. The maximum temperature in the cycle is 110 degrees Celsius. 1100 degrees Celsius, not 110. What is that particular value? Which temperature is that?
T3.
Very good. So the value of T3 is it is 1100 degrees Celsius. ಇದನ್ನ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಕೊಟ್ರೆ ಇದನ್ನು ಮತ್ತು 15 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಎರಡನ್ನು
288 Kelvin.
288 Kelvin.
1373.
1373 Kelvin. ಆಯ್ತು. Next is type. Determine the pressure and temperature at each point in the cycle. So what we are supposed to find out? P1, P2, temperature with the pressure alla. P3, P4. Similarly, T1, T2, T3, T4. Temperature and pressure at all points in the cycle. Next, what you have to find out? Compressor
WC.
work. Next, turbine work. I would just write in neat to find what all we need to find. P1, P2, P3, P4, T1, T2, T3, T4. Next, compressor work, turbine work. Next, what you have to find out? The cycle efficiency. What do you mean by cycle efficiency? Efficiency of the Brayton cycle. So that also we need to find out. Okay. Now, in this particular problem here, anywhere he has mentioned about efficiency of a turbine or efficiency of a compressor? Anywhere he has mentioned?
No.
So if he has mentioned, there is no concept of actual theoretical in this particular problem. It is just plain simple Brayton cycle. So you can eliminate all this. There is no need of dash because there is no mention of the cycle, this one, efficiencies of a compressor as well as the thing. It is just T1, T2, T3, T4. P1, P2, P3, P4. That's it. Okay. Okay. Let us try to find all the pressures and temperatures of all the point. Okay. Now, first pressure I would calculate one by one. Okay. Do I have the value of P1? Do I have the value of P1?
Yes, sir.
Yes.
Do I have the value of P2?
Yes.
P3? P3 unta?
No.
No.
Arre, P3 ilva? ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು P3?
Same as
How do I find the value of P3?
PVT conversion.
Okay, which PVT conversion equation, Anish? So I know the value of pressure at all points. So just write first heading what he has asked is pressure at all points. So P1 is being given, just write it as 0.1 megapascal. Just write it as given there. P2 is being given as 1 megapascal. Again, it is a given data. Now, what about P3? What about P3 now? And P4? What about these two? How do I find P3? How do I find P4? I know the value of P1. P1 is given in the problem. I know the value of P2. I need the value of P3. And I need the value of P4. How do I do that? Siddesh BN.
Sir, P3 is equal to 1.
Sir,
P3 is equals to 1. ಹೇಗೆ 1 ಅದು? ಯಾಕೆ 1?
Beta is
ಹೇಗೆ
equal to
ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೆ?
P2 by P1 is equal to P3 by P4.
Yeah. Sir, 2 base.
ಅಷ್ಟೆಲ್ಲ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಮಾಡಬೇಡಿ. You know the value of P2, right? You need
Straight
to
line.
calculate what is P3. So both are same, no?
Same.
Yes or no? Similarly, you know the value of P1. You need to calculate the value of P4. Again, it is an isobaric process, same value. Right? So, what I can write is P3 is nothing but it is equal to the value of P2, which is 1 megapascal. You will get 2 marks. P4 is nothing but the value of P1, which is 0.1 megapascal. And there ends our story. That's it. Pressure at all points is being calculated. Now, go for temperature at all points. Temperature at all points. Just list down the temperature at all points. T1, T2, T3, and T4. Out of all this, how many are given in the problem? How many
1
are
and
given?
T3.
Yes, T1 is 288. I would just take it 288 directly. Kelvin. Next, T3 is how much? T3 is 1373. 1373 Kelvin. Now, I need to calculate what is T2. I need to calculate what is T4. How? How? How?
By the equation, temperature ratio T2 by T1 equals to T3 by T4.
So, from PVT conversion equation, for which process you have to apply this PVT conversion equation? First for 1 to 2, which is adiabatic compression. Adiabatic ಗೆ PVT conversion equation ಏನಿದೆ? It is P1 by P2 is equal to V2 by V1 whole to the power of gamma, that is equal to T1 by T2 whole to the power of gamma divided by gamma minus 1. P1 by P2, P2 by P1 is beta. P1 by P2 is what? It is 1 by beta, that is equal to T1 value was 288. T1 value was 288 divided by T2 value. You have to find it out. And gamma value ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರಾ? Gamma value is being given in the problem. The value of gamma?
No, sir, not
No.
given.
Not given. See, carefully observe this. He has specified it as air standard. Correct? He has specified it as air standard. So I would just write here air standard. Air standard ಅಂತಂದ್ರೆ we are taking gamma of air. What is gamma of air?
1.4. 1.4.
1.4 is the gamma of air. I would take that 1.4 divided by 1.4 minus 1. Beta value ಎಷ್ಟಿದೆ 1 divided by 10 ಕರೆಕ್ಟಾ? ಈಗ ಹೇಳಿಯಪ್ಪ T2 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ in Kelvin?
556.04.
46
556.04.
556.04. So I would just write it here 556.04. Next, same thing for the process 3 to 4 if you apply, which is again adiabatic, but now it is expansion. Adiabatic expansion. Illi apply ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ P3 by P4 that is equal to V4 by V3 whole to the power of gamma that is equal to T3 by T4 whole to the power of gamma divided by gamma minus 1. From this, P3 by P4 can I directly write it as beta? T3 value is 1373 divided by T4. We need to find here whole to the power of 1.4 divided by 1.4 minus 1. Whereas the beta value is how much? 10.
10.
Now, give me the value of T4 in Kelvin.
$711.14 Kelvin.
711.14 Kelvin. So I would just write it here 711.14 Kelvin. Right. So temperature at all points we have calculated. Right. Next, pressure at all points we have calculated. What else we need to calculate? WC and WT. Third bit. Any difficulty in calculating WC? WC is what? WC is what? I told you it is mCp delta T, right? WC will be always from 1 to 2. It is mCp now. We have to write the temperature difference. For work, it is initial minus final. So it is what? T2 minus T1 or T1 minus T2? For work, it is initial minus final.
T1 minus T2.
So T1 minus of T2. Just write it here. mCp T1 minus of T2. Any thing which is given in the problem regarding the mass flow rate or mass? ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರೆ ಏನ್ರೋ ಮಾಸ್ ಬಗ್ಗೆ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ದಾರಾ? Anything given? Sushant ಕೊಟ್ಟಿದ್ದಾರಾ? Hazim?
No, sir.
ಕೊಟ್ಟಿಲ್ಲ. So you leave it. When you leave it, what happens? You see, you can take just Cp into T1 minus of T2. Okay. Substitute this. Cp value ಏನಿದೆ? Cp value ಏನಿದೆ ಏರಿಗೆ? What is the value of Cp of air? I told you we have to remember all this. Cp of air. What is the value?
1.11.
Check your internet and give me the value. Cp of air check ಮಾಡಿ ಹೇಳಿ ನನಗೆ.
1.17.
1.17. Sure.
Sir, it's in your notes.
Sir,
that I
1,
have
sir.
written.
1.00.
What is the exact value of Cp of air? Check in the internet and give me the value.
1, sir. 1.
1.00.
1, sir. 1 kilojoule per kg.
1, sir.
1 now. Sure.
Sir, 1, sir.
It is 1
Sir. Yes, sir.
1.005. You'll be having in the data handbook. No, just check how many of you have your data handbook. Just check there. The CP value would be given there.
Yes, sir. 1.005.
1.005 kilojoules per kg. Okay, I would take that particular value. 1.005 into T1 is how much? 288 minus of T2 is how much? 556.04. Okay, now check the units. You have substituted in which units and you are going to get in which units. So for CP, you have substituted in kilojoules per kg Kelvin. Correct? Cross. This is Kelvin. So Kelvin goes away. Whatever answer you get, that would be in kilojoules per kg. What is the answer?
Minus 269.38 kilowatt.
Kilowatt.
ಅಲ್ಲ ಸರ್ ಕಿಲೋ ಜೌಲ್ಸ್ ಪರ್ ಕೆಜಿ.
Check ಮಾಡು, ಸುಮ್ಮನೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬಾರ್ದು. You have to check and then say. Very good. Next, fourth point. Turbine work. Turbine work is m dot Cp into T3 minus T4. Correct? That is equal to m dot kottilla. So just take Cp into T3 minus of T4. Cp is same 1.005. T3 value was 1373. Okay. Minus of T4 dash, sorry, T4 is 711.14. Nav, just check the units. Already you have checked it. So whatever the answer you get, that would be in kilojoules per kg. What is the value?
665.16.
665.16 kilojoules per kg. So this is also done now, right? All these are done. This is done. Efficiency of Brayton cycle. Now, what is efficiency of Brayton cycle? Fifth point. We shall finish it off very fast. Efficiency of Brayton cycle is W net divided by heat supplied. Okay. Now, W net is nothing but what? W net is
WT plus WC
plus WC divided by QS. QS ಏನಾದರೂ ಇದೆನಾ ನಮಗೆ? Heat supply calculate ಮಾಡಿದೀವಾ? We need to calculate the value of QS. QS ಕೂಡ ಅಷ್ಟೇ. It is mCp delta T ne. But for heat it is what? For heat it is final minus initial. Q ಗೆಲ್ಲ ಏನದು? Final minus initial. Okay, final minus initial. Heat supply ಆಗೋದು ಯಾವ process ಅಲ್ಲಿ? In which process the heat is getting supplied?
First.
In which,
1 to 2.
In which process the heat is getting supplied? Whether it is from 1 to 2, 2 to 3, 3 to 4, or 4 to 1. In which process the heat is getting supplied? Heat supply happens in which process? 1 to 2 is adiabatic compression.
What one?
Next. Yes. 1 to 2 is 1 to 2 compression kana ali gas compress agodu. 1 to 2 is adiabatic compression. 2 to 3 is isobaric heat addition. So 2 to 3 alle ninige heat addition agodu. Next 3 to 4 is expansion in the turbine. Next is 4 to 1 is heat rejection from the system. So now we are supposed to calculate QS, which is from Q2 to 3. So therefore it is mCp delta T. Now I have to write the temperature difference. For heat it is final minus initial. So I have to take whether T2 minus T3 or T3 minus T4. Sorry, T3 minus T2.
T3 minus T2.
So I have to take it as T3 minus of T2. Pat calculate ಮಾಡಿ ಹೇಳ್ತೀನಿ ನಾನು. So you don't have the value of m dot or m. So whatever you do is you just take Cp, that is nothing but m dot into Cp into T3 minus T2 alla, final minus initial. So Cp into you are taking just T3 minus of T2. Same thing substitute madi patpata 1.005. T3 value was 1373 minus T2 value was how much? 556.04. 556.04. Now, whatever value you get, again it would be in kilojoules per kg, because Cp value is in kilojoules per kg Kelvin. Cross T3 minus T2 is in Kelvin. Kelvin goes away. So whatever the value you get, it will be in kilojoules per kg. What is the value of Qs? What is the value of Qs?
$821.0. 21.04.
891.04. While substituting for the efficiency of
21,
Brayton cycle,
821. 21.
821. Sorry. Oh, even though 821.04. While substituting the value of expression in the Brayton cycle, so make sure the numerator and denominator have the common units. So numerator and denominator are of kilojoules per kg and denominator is of kilojoules per kg. So now you can substitute it directly. So Wt is what? It is 665.16 minus of Wc is minus 269.38. 269.38 divided by, it is 821.04. If you multiply it by 100, you would get it in the percentage. So efficiency of the Brayton cycle is how much? In percentage.
Sir, Wt plus, sir.
Correct,
Wt plus.
huh? Very good. Wt plus Wc ne. But Wc is in minus, no? Minus
Okay,
260.
very good. Okay, sir.
So 48.2%.
It is 48.2%, and there ends your problem. Okay. So these were the two problems in the Brayton cycle. We will solve a couple of problems more. You can mark your attendance in the Google sheet which I have sent you. Have a
Sir,
nice
yes.
day. Take care.
Sir, ನಿನ್ನೆದು attendance.
ನೆನ್ನೆದ ಕೊಟ್ಟೆ ಒಂದೇ ನಿಮಿಷ ಲೈನಲ್ಲಿ.
Okay.
So you can mark your attendance and leave. Okay, take care. Attendance ATD. ರಜತ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಇನ್ನು ಮಾರ್ಕ್ ಮಾಡಿದ್ದೇನೆ ನಾನು.
Okay, sir. Thank you, sir.